So another main topic that we discussed that is associated with reversible reaction, it is basically a principle that is called Le Chatelier's principle. Let me first write down what the principle says itself and then I can explain it. It basically says that when a change is made to a system, and by system we basically mean the reaction itself, in equilibrium, and that reaction is in equilibrium, the system or the reaction moves to oppose the change. It moves to oppose the change. This is what the Le Chatelier principle is saying. Let's go through the words again. It's saying that when a change it is made to a system that is in equilibrium, the system will be influenced, but it will be influenced in a way that it moves to oppose the change. Okay, now let me explain this. A plus B forming AB. Let's say this is in equilibrium right now, and the conditions at which it is in equilibrium is, let's say the temperature is 55 degrees Celsius. So at 55 degrees Celsius, this particular system it's at equilibrium. And one more thing here is that when reactions they are in equilibrium, to make things easier for you, think of it as that the reaction is stable. And when the reaction is not in equilibrium, the reaction is unstable. If you remember when we were talking about the ionic bonding or the bonding chapter as a whole, we discussed that the reactions, they basically happen to achieve stability, right? Each of the atom it's losing or gaining electrons because they want to become stable. So in chemistry generally, everything that is around us, it is trying to achieve stability or it pursues stability, right? So that's why the reaction itself, they are going to favor the stability over the instability, and stability it is associated with equilibrium. Now the equilibrium is at 55 degrees Celsius. Let's say I decrease the temperature to 40 degrees Celsius. When I decrease the temperature to 40 degrees Celsius, the equilibrium will be disrupted. This system will no longer be in the equilibrium, and now what it will do is the system will be influenced in a way that it will try to achieve stability or it will try to achieve the equilibrium point once again. Now how is it going to do this exactly? That's where the comes opposing the change comes in. What that means is the temperature was 55 degrees Celsius, you decreased it to 40 degrees Celsius. It's going to oppose this change in the temperature that you have just made and will try to go back to the 55 degrees Celsius temperature so it can achieve the equilibrium point again. That's what we mean by opposing the change. Similarly, let's say that now maybe the equilibrium was established at 35 degrees Celsius. And what you did was you changed the temperature, you increased the temperature to 45 degrees Celsius. Now it will try to lower the temperature back to 35 degrees Celsius so it can achieve stability once more. Do you get the general idea here what's happening in Le Chatelier principle?
Yeah.
Okay. Now when we say that it decreases the temperature back or it increases the temperature back depending upon the temperature at which it was in equilibrium, how exactly is it doing that? How exactly is the system increasing or decreasing the temperature? Now first thing is we have different factors that can influence the equilibrium position or that can disrupt the equilibrium. So let's go through each one of them one by one. The first one is temperature. Okay. Now let's say for example you have, let's say 2NO2 and it is forming N2O4. Both of them they are gases. Okay, let's say this equilibrium it is basically established at 30 degrees Celsius. What you do is you increase the temperature to 35 degrees Celsius. the system will act in a way that it will try to lower this temperature back to 30 degrees Celsius. How is it going to do that? Basically, for each reversible reaction, there are energy changes that are associated with it. Let's say, for the sake of example, that the forward reaction, it is exothermic and the backward reaction is endothermic. One important thing here is that in a reversible reaction, if the forward reaction is exo, then the backward reaction is always going to be endo. If the forward reaction is endo, then the backward reaction is always going to be exo. So they're always going to be opposite to one another. And the amount of energy that is being, let's say in this case, been given out in the forward reaction, it's going to be equal to the amount of energy that is being absorbed in the backward reaction. So let's say in the forward reaction, minus 30 joules are being given out. In the backward reaction, 30 joules of energy would be gained. So the type of energy change is going to be opposite to one another in each direction of a reversible reaction, but the amount of energy that is being transferred, it's going to be the same. Do you get this point?
Yeah.
Okay. Now, let's come back to the temperature point. So we are saying that the forward reaction is exo, the backward reaction is endo. When you increase the temperature from 30 to 35 degrees Celsius, it will want to drop the temperature back to 30 degrees Celsius. How is it going to do that? It's going to favor the endothermic reaction. So more and more heat is absorbed, so the temperature can drop back to 30 degrees Celsius. So the rule of thumb here is that when there is an increase in temperature in a reversible reaction, it favors the endothermic reactions. Why? Because endothermic means it's going to absorb energy and it's going to decrease the temperature back to our desired point. Do you get this part?
Yeah.
Similarly, when there's a decrease in temperature, so let's say for example, you decrease the temperature from 30 degrees Celsius to 25 degrees Celsius. It will try to go back and regain that 30 degrees Celsius point. So what it will do is it will want to release more heat, so the temperature increases back to 30 degrees Celsius. So the rule of thumb here is that when there's a decrease in temperature, it favors an exothermic reaction. Right, so these are two things that you should memorize. An increase in temperature favors the endothermic reaction, and a decrease in temperature, it favors the exothermic reaction. Okay, now one more thing here is, when we say it favors endothermic reaction or exothermic reaction, how is the equilibrium going to be affected? Favoring one type of reaction affects the equilibrium position, and equilibrium, it shifts to one particular side. If the endothermic reaction is being favored, that means the backward reaction is being favored, which means this side of the reaction is being favored, right? Because N2O4 is getting converted into NO2 in the backward reaction. So we say, if it's favoring endothermic reaction in this particular example, we are going to say that the equilibrium shift towards the left side. This is the left side to NO2. Similarly, if there's an increase in temperature, it favors exothermic reaction. Exothermic reaction is the forward reaction, which means that now this side of the reaction will be favored. So we say that the equilibrium position, if shift towards the right side. Do you get this point as well?
Yeah.
Okay. Now we extend this a little bit more and we say, after the shifting of the position of the equilibrium, if the equilibrium has shifted towards the left side, which is the NO2 side, more NO2 will be produced, right? So think of it in this way: endothermic reaction is being favored, equilibrium position is being shifted towards the left side, that means more NO2 will be produced. So we say that more reactant will be produced in this case, or more NO2 will be produced in this case. If we talk about decrease in temperature, that favors exothermic reaction, which shifts the equilibrium to the right side, that would mean that more N2O4 is produced, or more product it will be produced. right? So we start with what the change has happened. Then we go to the point of what type of reaction is it going to favor. Is it favoring the forward reaction or the backward reaction? How is it going to affect the position of the equilibrium? And is it going to cause an increase or decrease in the amount of the reactants or the products? Right? Is everything clear up till this point?
Yeah.
Okay. So now you have understand the general idea of what's happening. The other factors would be more easier to understand. So first one is temperature. Remember, when we talk about temperature, we talk about the energy changes, the exothermic part or the endothermic part. Now the second factor that we have is, it is basically the pressure. And when we talk about pressure, always remember that in case of Le-Chatelier principle, we will be only considering the gases. Why is that? Because pressure generally only affects the gases. When you apply a pressure on a solid thing, it does not really change, right? For example, the chair I'm sitting on, if I start applying more pressure on the chair, it's not that the chair is really going to change its shape or something is going to happen to the chair unless and until, I crush it under something. But pressure generally, they affect the gases, because in gases, the particles, they are far apart from one another, right? So when you apply pressure to them, they have some spaces in between them, and that is why they can come closer to one another like this. And the particles, they can come closer to one another. But in solids, for example, let's say the particles are already tightly packed together, there's no more space for them to even come closer to one another. That's why pressure does not affect it. So first point here is pressure only affects the gases. Now let's take an equation, same equation as we discussed earlier, 2NO2 gaseous, and we have N2O4 gaseous. You might remember from the properties of the states of matter that we discussed in the earlier chapter, and we discussed that gases, the higher the number of gaseous molecules is, the higher the pressure would be. Why is this? Because when we say pressure is basically derived from the collisions of the gaseous molecules with the walls of the container. The more the collisions are with the walls of the container, the higher the pressure would be. So obviously, as you increase the number of the gaseous molecules, the frequency of the collision with the walls of container is going to increase as well, right? So remember this first point here. Now let's say this equilibrium in this particular reaction, it is achieved at 2 pascals. What you do is, first you increase the temperature to 3 pascals. When you increase the temperature to 3 pascals, it will try to oppose the change and achieve the 2 pascals pressure again. Now how is it going to do that? It's going to favor the side of the reaction where there are less number of molecules of gas present, so the temperature, it can drop back to 2 pascals, right? So the rule here is that if the pressure has been increased, then that side of the reaction will be favored which contains less number of gaseous molecules. Similarly, now let's say from 2 pascals you decrease the temperature back to 1 pascals. If you are decreasing the temperature, it will try to increase the temperature back to 2 pascals. That means it will favor the side of the reaction that contains more number of gaseous molecules. So if you decrease the pressure, it will favor the side that contains more number of gaseous molecules. Do you get this part up to this point?
Yeah.
Okay. Now the next thing is, how do we figure out which side contains less number of gaseous molecules or more number of gaseous molecules? To do that, what you do is you take a look at the coefficients that are written with these gases. With NO2, there's 2 written, so we are going to consider that there's 2 molecules of gas that are present. And with N2O4, there's 1 written, so we are going to consider that it only contains 1 molecule of the gas. Now, when we say increase the pressure, moves the equilibrium, or favors the reaction that contains less number of gas molecules. Which side contains less number of gaseous molecules, right side or the left side?
The right side.
Exactly, the right side. So what's going to happen is the forward reaction will be favored. Why? Because there are less number of gaseous molecules present on the right side. So what happens is equilibrium position, it's going to shift towards the right side and more amount of N2O4 will be produced. Similarly, when you decrease the pressure, it's going to favor the side that contains more number of gaseous molecules. So we are going to say that the equilibrium position shift towards the left side because there are more number of gaseous molecules that are present, and that is why more amount of NO2 it will be produced. Right? Do you get this point?
Yeah.
Alright. So that is it for the pressure part. Now, one thing here is what happens when you have got the same number of gaseous molecules on both sides. So for example, let's say 2A is forming 2B and both of these are gases. Now in this case, on the right and the left side, there's same number of gaseous molecules present. If there is same number of gaseous molecules that are present, you are going to say that the pressure, increasing or decreasing the pressure, it's not going to affect the equilibrium position. Then there is no effect on the equilibrium position. And now let's say, for example, what happens when there are solids or liquids also present in the equation. Let's say C is a solid and then B is a liquid like this, and it is forming, let's say, 2AB plus C. C is a solid and AB is a gas. Now in this case, can you maybe tell me what is the number of the gaseous molecules that are present on the left side?
Two or one.
2 moles. 2 molecules are present on the left side. Perfect. What you have to do is, if there are solids and liquids also present in the equation, you are not going to consider their number at all. You just ignore them and you just count the number of the molecules of the gas. So 2 here. And what about on the right side? What's the number of gaseous molecules here?
2.
2 as well. Perfect. So again, you don't consider the number of the C and you just go with 2 like this. So there are 2 molecules of gases present on the right side as well. Right, so that's it for the pressure factor. Now, the next factor is the concentration. Okay. Now, let's say we have ICl reacting with Cl2 and it's forming iodine chloride, ICl3. Okay. Now in this case, reversible reaction, this is your reactant side, this is your product side. What happens if I increase the concentration of ICl3? If I increase the concentration of ICl3, I add in more ICl3, the system, it will oppose the change by trying to decrease the concentration of ICl3 back. So what it's going to do is it's going to favor the backward reaction. So more and more of ICl3 gets converted into the reactants. So the concentration of the ICl3, it can drop. But what happens if instead of increasing the concentration of ICl3, I decrease the concentration of ICl3? So let's say it's 5 mole per decimeter cube, I decrease it to 2 mole per decimeter cube. The system will oppose the change by trying to increase the concentration of ICl3 back to 5. And now how is it going to increase the concentration back? What it's going to do is it's going to favor the forward reaction. So more and more of ICl and Cl2 can react with one another and form ICl3. So the concentration can increase back to 5. Right? So we say when the ICl3 concentration is decreased, the equilibrium will shift towards the right side because the forward reaction is favored. But if ICl3 concentration it is increased, then backward reaction will be favored, so equilibrium it shift towards the left side. Make sense?
Yeah.
Similarly, you can apply the same concept to the reactant sides as well. What happens if the concentration of the reactants it is increased? If the concentration is increased, the system will try to decrease the concentration back. How? It will favor the forward reaction, so more and more reactants they get converted into the products, so their concentration can drop back. But if the concentration of the reactants is decreased, now we would want to increase the concentration back. So the backward reaction will be favored, so more and more of ICl3 gets converted into Cl2, so the concentration of the reactants can increase back. Right? This makes sense as well?
Oh, yeah.
Okay, perfect. So these are the main 3 factors concerned with Le Chatelier principle: temperature, pressure, and then concentration.